I forgot to do something. I was gonna close that and then reopen it. Activate source. There we go, and activate. There we go. I think I fixed the YouTube and whatnot not working. All right, let's get back to this. This is gonna be a long, another day, another dollar. Sorry, not another day, another dollar. Another day, another day. Let me just make sure that my chat is actually working correctly. I really got to turn that off. I'm going to do that right away. Okay, sweet. Sound settings. Where is the... is it this? No. No. What? Windows 11, turn off alert. Setting system notification. That's not what I want. Windows 11, turn off system sounds. Go to settings, system, sound, and click sound control panel. Oh, look, that thing that's not there. Oh, okay. Windows 11. Open. Where is it? Yeah, I did that. And it did. I click sound settings and I get this horrible piece of shit. Oh, there it is. Oh, thank God. I do this because I move my keyboard, and when I move my keyboard, it triggers a audio sound, right? A ba-dink a dink or whatever, a bink a dink a doo or whatever the fuck it is, and I hate that sound. It actually irritates me. So I disable it, and it turns out that they want to hide it. 'Cause reasons. Okay, so where were we? We were here. We were here in this great
It over
documentation.
here with normal components. So let's select the parent game object. And this one over here, let's give the unit the shape. So let's give it a regular capsule collider. Then let's set up the settings. We can see over here on the scene view. So let's make it a little bit higher. So with a height of 2, for the radius 0.5. Yep, that looks good. And let's just lift it up a little bit so it doesn't touch the floor. Let's say 1.1. Okay, yep, so there's our unit collider. And again, just like this, just by attaching a capsule collider. And now let's test. And if there it is, the unit is still moving exactly as intended, except now it is doing so using physics. Over there into runtime mode, and up here we do see all of the various components. Now our goal, like I said, is to move this unit using physics, meaning for move it, we actually want to modify the velocity, and yep, we can see it right here. This is the component we want to modify, the physics velocity. This one has a linear for the linear velocity, and angular that affects rotation. So instead of
Okay, wait. So I forgot to reopen that. Is that the right one? Yep. This is Unity Hub, right? Yeah. Let's just pin this. We'll be here all week. So I was looking into loading screens in Unity. And it is kind of interesting. Okay, so let's go back to my pedestrian. There's the physics collider. But because this doesn't have a rigid body, it's missing some stuff, right? Yeah, there we go. Okay, so if I save and try this, save, we'll hit play and we'll see what happens. But that box went bye-bye. This box here. The speed is too high. Let's put this on 10. Oh, interesting. Oh right, my truck doesn't work anymore for some reason. I forgot about that. Uh, and close all those. Unity vehicle, unity physics, dots physics. So yeah, I don't really care about the skinning thing. This does bother me though, because like this should be just working, right? What was the thing that I installed? Manager. Right, it was Unity physics. Unity vehicle. It's likely due to a conflict between the old physics system and the new Unity physics system, potentially caused by incorrect setting in the vehicle rigid body component. Okay, so how do I fix it? Make sure your vehicle rigid body is set to the appropriate type, the kinematic, if you want to fully control the vehicle's movement. Where's my player? There's my player. Is this what it is? Is that all it was? No. Hmm. Neat. Recommend creating a very simple scene that reproduces the bug, including the necessary options to reproduce. Here it seems to be rigid body with those settings plus a. I thought I needed a rigid body. Do I not need a rigid body? No, I need a rigid body, right? Yeah, because without a rigid body, there's nothing, there's no mass, right? Okay, I'm gonna try and update my mass, right? Let's go to 1000. Wait, what was it? It was 8500, right? Let's go to 1000. Maybe I'm not applying enough force. No, it's not that. Could be. Do look a little in the ground here. Maybe this. I wouldn't imagine it would be this, because I would imagine that it would push me out, right? let's make sure that this is working. Apply gas. So we're applying the force. So it's being applied. It's just it doesn't work. Okay, so I might have to build my own. Fuck. Is the vehicle system incompatible? This one's my asset, right? I have this, which is not what I want. But maybe the answer is to build my own system. As absolutely shitty as that is. I didn't want to, but I might have to. Unity. There was a video. This one's really good, but that's not the one I was thinking of. This guy's really good, but he's using a system that just stopped working for me. Where? Oh, where? Maybe this one. No, this isn't it. Unity vehicle. This one. Is it this one? No, this one's using the this one's using the internal one. This one.
Welcome back to Ash Dev. Today we're starting a tutorial series on creating an arcade-style car controller in Unity. In this first part, we'll delve into the intricacies of suspension logic. Stick around till the end for some valuable insights. Let's get started and understand the approach of suspension first. Imagine we're shooting rays from each corner of the car, all pointing downwards. Now, if we apply a force to the car as a car bounces off, I'll explain how we achieve this later in this video. Now let's start with our project. Create an empty, change its dimensions so that these will move according to their positions. Now, let's dive into the coding part. Begin by creating a script named car controller.
Okay, so what I'm gonna do is we're gonna actually build this, okay? So bear with me here. We're gonna build this because if this isn't going to work, I'm going to find something that will. Create new script, mono behavior, custom vehicle controller. This guy makes a great. They made a great video. I don't know why Windows keeps doing that.
In this script, add a header called references. Beneath this, declare a rigid body named car RB to represent the car's rigid body. Then, create an array of transforms named ray points. This is where we'll store all our ray points. Following that, define a layer mask called drivable. This layer mask will help us specify on which surfaces the car can drive, ensuring the car won't accidentally climb onto things like walls or other undesired objects. Next up, add a new header titled
Yay, it's working. The chat is working today. Also, sup. Yeah, so uh I think I need to create a custom controller from scratch for the vehicle because it just stopped working altogether. Um it's firing everything, but it just doesn't work anymore. So I'm just like, oh, well, fuck. It looks like it's probably something to do with the Unity physics being incompatible, like the Unity physics plugin being incompatible in some ways with the default one or whatever. So I'm just like, oh, okay, so I guess I have to build my own now. So let's go through that process.
Suspension settings. Under this, introduce 4 float variables: spring stiffness, rest length, spring travel, and wheel radius. Now in the start function, get the car RB. Let's break down what each of these variables mean. Rest.
Okay, so what we're gonna do is we're gonna start with our mesh. Okay, so let's go to our prefabs. I'm gonna close that. We're gonna go to prefabs, vehicle. We have this. I'm gonna delete. Yeah, I'm gonna delete this. Wait. I wanna do this. Original prefab. There we go. And then this one I want to delete. There we go. And then this one here will say truck coon. We'll just call it truck coon old for now. What we want is this mesh for the truck. So we go to the mesh, we go to vehicles, default truck. All right. So we're going to start with a create an empty. We're going to say truck coon. And then inside the truck coon, we're going to create an empty. And we're going to say mesh. And we're going to add the mesh filter, mesh renderer, because this is just a mesh. And we can, what? I feel lied to. This is a mesh. It's not nothing else. Why does this hate me? There we go. And then this is the material, right? There we go. Interesting. Okay. Then here, right, we're going to do that thing that they suggested. That one? No, it's this one. See. Yeah, they suggested putting it not directly on the unit. Interesting. I can get behind that. What do they call it though? Waypoints? Call it wheels. Left. Rear right. Oops. Rear left. There we go. And I think I want the lefts to be first. just because I've got them the same there. There we go. There we go. You happy? Paste. And then I think it's just minus on the A's, right? Yeah, there we go. Then the rear left. I should probably do rear right to be fair. Because rear right is oops. It's gonna be easier to pin down. There. Right about there. Sweet. So then we would take this and we would paste it into here. And then we would change this to be a positive and we'd be done. Beautiful. Now we can go back to perspective mode. There we go.
Balance and performance. Also, label them according to their positions. Now, let's dive into the coding part. Begin by creating a script named car controller. In this script, add a header called references. Beneath this, declare a rigid body named car RB to represent the car's rigid body. Then, create an array of transforms named.
So what's the point of what's I'm kind of curious. What's the point of using serialized fields if public just gives you access to it? I'm sure that there is actually a reason. But I'm curious. Oh, okay. So like, wait. No, because like, I thought that like just adding. Okay, so if I do public float my int, right? And I build this, and I attach this to the thing. Right, so I go to here and I go, where is it, scripts? And I go custom vehicle controller and I do this. Right, there's my int. And it didn't need to be serializable. So when you say like, so Unity can see it, what exactly does that mean? Oh, for private? It can't see private variables. Well, it's not supposed to. Okay. So if I have a private variable, then I can. So if this is private and I want to be able to use it, then I would do the serialized field, and then it would work. That makes sense.
Ray points. This is where we'll store all our ray points. Following that,
That's not what that is. Okay, so we're gonna do serialize field. I don't know if this needs to be private. Rigid body. Vehicle body. Serialized field, private, transform, wheel, transforms. I don't like the name. I gotta think of a better name. I misspell vehicle for like the 100,000th time. Damn it. Did I misspell it here too? Yeah, I did. Edit. Rename. There we go. What's the problem here? Ah, interesting. Serialized field. Oh. Wait, so this should be this? Wait, but this needs to be entirely lowercase? No? Oh. But this is a property. These are both property. Or is it like I don't know. Yes. Oh, for the get set thing. Okay. Yeah, that makes sense. Okay, so that would be vehicle body. Did I do something wrong here? Oh wait, no, that's because it needs to be a rigid body, and this is not a rigid body. Add rigid body. And mesh collider. There we go. And if we come to here, then we can do rigid body. There we go. And then these wheels have the transforms, but I did not make them a list. One, two, three, four. One, two, three, four. Would it be wrong to sorry, would it be wrong to create wheel properties? Like public class custom wheel controller. Like, would this be wrong? And then this could be, instead of it being transforms, it would be like custom. And then this has a transform. Because this would have a transform, right? By default, because it's a mono behavior. And all mono behaviors have transforms. Maybe? So then I could do this, and I could add a component of interesting. Create folder, custom vehicle. Okay. For now, I'm going to not do... Where's my custom vehicle controller? There it is. For now, I'm not going to do this because it adds extra complexity that I don't want to deal with. There we go.
That, define a layer mask called drivable. This layer mask will help us specify on which surfaces the car can drive, ensuring the car won't accidentally climb onto things like walls or other undesired objects. Next.
How would it climb on walls? I'm going to have to understand layers at some point. Right now seems like a great idea. Unity layers. Damn ads.
Hey, what's up guys? John Spaceskull here. Welcome back to another game dev video. So today I want to talk to you about layers in Unity. Now it's a bit of a complex topic for beginners because layers can be used in many different critical ways, and they're not to be mistaken with layers in Photoshop or Illustrator or other kind of video or graphic editing software which share the same layers name. It's very different. So let's start by looking at how we actually create a layer. So to do that, I'm just going to jump over to Unity here, and there's two ways we can create new layers. We can start by clicking an object here with the ground, and with a layer drop down here, we can select add a layer, and we can add it here like so. The other way is to go directly to this layers drop down in the top of the Unity IDE and click edit layers, and from here under the layers drop down we have these empty slots. So it's in these empty slots here that we want to create some new layers. So I'll go ahead and do that. We'll create one called background, another one called player, another one called ground. So after you've done that, you then have to actually click on the objects that you...
So wait, is it normal to like have a lot of layers, like custom layers in Unity?
want and assign those layers. See, you can see these new created layers here. Now there are some default layers here that Unity has created as part of the Unity engine. So let's assign background to background. We'll make our player a player layer, and we'll make it ground for the ground. Okay, but now I'm going to get into the reasons as to why you want to use them, or rather why you have to use them, because they are, like I said, a critical part of the Unity workflow. So the first purpose is workflow optimization. I can go into this layers dropdown, and from here, I can toggle the visibility of different layers. And you can even lock the layer, so that way you don't accidentally click on things you don't want to be clicking on. Now you can see I actually do something very similar in my own game Blood and Meat, where I have a terrain layer. I've got a lot.
I'm not gonna lie, I kind of want to play his game. I don't know if anybody has seen like his videos about Blood and Meat. It looks kind of good.
Layers actually, so don't be distracted by those, but I've definitely got a background layer. So turning off the background is one very nice way to work. And I also like to lock this terrain layer, so I don't accidentally move my terrain pieces around. That can be quite annoying. All right, so purpose number 2, collision. Now collisions in Unity.
His video editing has gotten better because the Mario pipe sound that he's using is fucking terrible.
Are directly linked to the layers. So there's a direct tie between them. Now, if you go into your Unity IDE, under the edit menu, under project settings, you'll have various options. And under physics or physics 2D,
yeah, his video
you'll have
editing
this
is improved
collision
a lot.
matrix, layer collision matrix. Now, this has all the different layers in your scene listed, and it makes a cross check as to what layers you want to collide with other layers. By default, it turns it all on. So what you want to do, you want to kind of customize this to suit your game. So you have different collisions, like for example, the player I want to collide with the ground. So I've clicked this box here. I don't want the UI to collide with the ground or the player to collide with the UI. So it's a little bit of a clumsy system that they've set up here, but it does kind of work. It would be good if they added like a deselect all button, because you can, depending on how big your collision matrix is, you can end up spending a lot of time toggling these. And I'll just jump over to my own game to show you the chaos, well, organized chaos, as I put it. And you can see here I have a very finely calibrated.
I am so confused here as to like why. Actually, no, I guess it. No, wait, no, it doesn't make sense. Does it? Oh, no, it does make sense. Okay. I actually prefer. Okay, so in this one, I think that the way that Unreal did layers, I think is easier. UI wise, like their UI, I think is better. But also, yeah, no, the I think the UI in Unreal for this is probably better. In my opinion, I'll show you the UI for Unreal for this, and it will explain the difference. No, that's not what I wanted. God damn it! I just wanted to open the game. This is a whole lot of things that I don't care about. Thanks, Epic. That's what I want. Let's see, local projects. I was learning Unreal, but jumped into Gas too soon, and it turned me off now. Oh yeah, Gas is massive. Absolutely huge. Okay, so if I go into TruckCoon, for the most part, right? Like you are going to need to make what would be effectively new layers in Unreal when you're making a game. But they're not as critical. Maybe. Actually, I don't know. It's hard to say. It really depends on your game. But the idea is still there. So if we open this up. If I open up the project settings and I go to colliders, wait, what was it? Sorry, I don't do this very often. There it is, collisions. Right? Okay, so I have my ragdoll and my ragdoll trace, all kind of irrelevant. But here we can see no collision, and if we double click on it, we can see this. So these are the settings for the colliders in Unreal, right? So you have your ignore, and if you switch these to ignore, it just flat out ignores that, right? Then you've got your overlap, so it will generate overlap events, and block will generate overlap and block events. Yeah. So I think that this is one definitely firmly in the Unreal category. Like there's definitely been things that have gone back and forth in so far. Like the Unity vehicle system, like the base Unity vehicle system is much simpler. Much simpler. I imagine that there's probably like a reason for that. Like there's a lot in the Unreal vehicle system. But it is unless you know and understand vehicles, it is so hard to tune a vehicle in Unreal, right? Because you've got your gears and your shifting and stuff like that, and you need to do like all the different gear maps and our gear ratios and all of that. Like you have to like actually understand all of that, and I understand none of that. I'm not a car guy. Right? So I don't understand any of this. And I'm just sitting there in Unreal and I'm just like, I don't understand how any of this correlates to speed.
Calibrated collision matrix. Now what this does is it actually improves the performance of the game because there's no collision redundancy. I'm not having layers being considered for collision against unrelated unnecessary layers. It's only looking at collisions between layers that I have deemed are worthy of some kind of interaction. So the third core purpose is the camera and rendering system.
that doesn't really work though, because like at the end of the day, okay, so it doesn't really end up working because at the end of the day, it's not about you okay, so to get the audio for a vehicle to sound right, you need RPMs. So you still need RPMs. And then RPMs relate to the gear. Right? But I don't understand that relation. That relation is like I've like my cousin tried to explain it a little bit to me and I'm just like I don't really get it.
Now, in Unity, you can tell the camera what it should render. So in this scene here, if I click on the main camera and look at the property inspector, you'll see there's a value called culling mask. So this is a value which determines what we want to show. And you can see by default, Unity has set it to everything. It's got the list of all the layers. So if I just set that to nothing, you can see here in the camera preview that now it's not showing anything. So from here now, we can actually fine tune what we want to show the player. Background, the ground, and of course the player. And then we can kind of mix and match and find various other options. In my own game, I have several cameras that are rendering different components of the scene. I have one camera which renders just the background, another camera which renders just the foreground, and another camera which renders just the play space. So you can see here on my main camera, I've got an orthographic camera, a perspective foreground camera, and the main camera, which is also a perspective camera. So you can see here, this main camera is only rendering the background. Okay?
That's kind of interesting. I never would have thought about that.
This orthographic camera is rendering all the stuff on the action level of the game. And this foreground camera is only rendering the foreground assets. If I click on those foreground assets, you'll see this foreground plant is set to the foreground layer. Very useful, very powerful, very efficient. So the fourth way in which the layers are useful is for actual code. And you might see often layers being used in this bitwise layer mask fashion to check foreground. This is particularly prevalent when using line casting or ray casting, where the ray will look for a particular layer to intersect to check if it has made contact with an object on a particular layer. So another important thing to note, there are only 32 layers in total at your disposal, 8 of which are being used by Unity. They've reserved those layers for like future updates and things like that. So you have to be very careful with how you manage your layers. Now in my own game, I've already maxed out the layers, and I'm often revising my code implementations to work with that limit. So why 32? Well, behind the scenes, Unity is using an integer to store the layer mask, and an integer only has 32 bits of storage space. So as a result,
Chrono. Do you know why they're using a 32-bit int for this? Like, do you know how that works?
we have 32 layers. So we
I
have to
imagine
work
you do.
within that limitation. So I hope you found this video useful. This video was actually requested by Patreon supporter Gradius. So thanks for the request. I hope
It starts on phones? No, so the reason why it's a 32-bit integer is because have you ever done bit fiddling or bit masking? Yeah, so it's just using bit masking. That's why it's an integer. I think Unreal's doing the same thing, but I don't know what if they're using a 32-bit or like what type of. I think there is a limit to how many you can have, but I don't know what it is. Well, they could use 64. They could use a 64-bit. So a 32-bit integer is not more performant than a 64-bit integer on a 64-bit machine. They're the same performance. So what happens is, I am a bit surprised that they're still on 32. Fucking silliness. There we go. So what happens is if I have a 32, oops, why is that not working? Where's my brush? Can I have a white brush, please? No, maybe. Did this change or something? Like, what's going on here? Why is all my stuff black? I specifically clicked this and then I clicked white. Oh, do I have to do? I have to do this one. Ah, God damn it! It's so annoying. Okay, here we go. No, I was just talking about the bit fiddling. Like, it's surprising how many people don't know about bit masking. But like, what happens is if I've got a, so everything that goes through the processor is a register, right? It has to be processed through a register. registers are fixed, right? So on a 64-bit processor, this is going to be a 64-bit register. It means that there's always 64 bits, right? Now, to Intel 64-bit. I think that it's been a while since I've looked at it, so give me a second here. I haven't done sorry, I haven't done assembler in a while. Okay, so yeah, so like you've got EAX, right? AX and AL, right? So EAX is your first 32 bits, right? And then this is also split up here into 16 bits and 16 bits, right? And this is empty space that's not being used if you're using a 32-bit. But it doesn't change the fact that this is still here, right? So processing a 64-bit integer on a 64-bit system is the same speed as processing a 32-bit integer on a 32-bit system, or a 32-bit integer on a 64-bit system. There's no performance. There shouldn't be any performance system. Yeah. So this is like a small sheet. It's horribly laid out. But if we do, maybe there's an image for this. Yeah, here we go. This is how they work, right? So you've got your 32, and you can access a high order 16-bit or a low order on a 16-bit for 8 bits, right? And you have access to all of this in a 64-bit space, right? So here you have EAX, right? And then there's the R. If you put an REAX, right? So here we see RAX, EAX. So RAX is the 64-bit register. EAX is the 32-bit register. And then you've got the lower 16 bits, which is AX, and then the lower 8 bits, which is AL, right? And then if we look at this, we can see there's also AH, which is the high order 8 bits, right? So if I've got, you know, RA, right, is going to be 32 bits this way, tacked on here. And then we've got EAX, which is the 32 bits here, right? And keep in mind that 0 is like the first digit is right here, and it goes this way. I guess I was just running on a mishmash of information. Well, it's fair because like there was a long time where this was like a huge performance problem, right? So if you think about it, right, if I've got a 32-bit register, if the 32-bit register is the largest thing that I have access to, then, and I can only ever guarantee that it's going to be a 30. Actually, this is probably why it's still 32-bit, is because if I can't guarantee a 64-bit register, it is horribly inefficient to use any 64-bit integer, right? Because like we have to take EAX and combine it with EBX and do some additional work to get these to be to work as a singular registry, and it just doesn't make that much sense, right? And with how portable Unity is, like I mean for like different architectures, it's very likely that they still support architectures that they can't guarantee are 64-bit. So that's probably why it's still 32-bit. Yeah. And I'm guessing it has to do with phones probably, or like a legacy reason for phones. But anyway, sorry. So back to the main topic of like it being, so a 64-bit, regardless, it's going to process these 64 bits. You could make an argument that like, no, because it still has to be held in cache that way too. Like, actually, I guess like when it's in the cache memory, it I'm not sure if it's stored as a 64-bit integer regardless when it's in cache. But when it goes into the registry, at least, it's always a 64-bit integer. It's just padded with zeros, right? Yeah. There was going to be massive improvements in Unity 7, but the new CEO said don't do it to keep back compat. That makes sense, right? Like, although like I could see them potentially. Actually, I don't know if it would make a huge like like a huge massive breaking difference if they went with 64-bit layers in Unity 7, because I don't know their code base, but yeah. So this is how registries work. Yeah.
Next up, add a new header titled Suspension Settings. Under this, introduce 4 float variables: spring stiffness, rest length, spring travel, and wheel radius. Now in the
I like bit masks as well. They make me happy.
start function, get the car RB. Let's break down what each of these variables mean. Rest length is the standard length of our theoretical spring when it's not being compressed or stretched. Spring travel is the maximum distance our spring can either compress or extend from its normal position. We will use this to calculate the force to apply based on how much the spring has compressed or extended relative to this maximum travel distance. Spring stiffness represents the maximum force our spring can exert, which occurs when it's fully compressed. Now let's take on the suspension logic. Start by creating a function named suspension. Inside this function, declare a raycast hit variable named hit to hold data from the raycast hit point. Then, introduce another float variable named max length, which represents the maximum length of the spring, calculated as the sum of rest length and spring travel. Next, wrap all these operations in a for each loop, since we need to execute them for each ray point. Thus, for each ray point in our ray points array, we'll apply the following logic. Use an if statement to shoot a raycast from the ray point's position in downwards direction. Use out hit to store the ray's hit data. The ray's travel distance should be the max length of the spring plus the wheel radius, ensuring the ray.
See here. Ray position minus ray position up. Dot up. That would force it down, yeah. Okay, so we take the ray. So wait, that's not all.
Ray covers the entire length of our suspension components to be able to reach the ground. The raycast will check against the drivable layer mask to determine valid surfaces. Now,
okay, so we've got physics raycast. So we take a ray point dot position, right? That's our starting point, and then we've got the ray point dot up, and we negate that, which means that it's going to point down. So that's the direction we're going to. Out hit, which I'm not sure why that's not a variable, like that was created outside. Oh no, it is. Oh, okay, it is. So wait, why is it called? Why do we have to put the out there? Interesting. Is that what makes it a reference? Whatever. We'll come back to that. And then we've got our actual length, which is the wheel radius, and then we have the thing that we're looking for, which is drivable. Okay. Huh. So everything has a layer, right? By default. Does it just not work like a pointer? Like a reference pointer when you pass it in? Right, because like the right, like if I had my function, right, and I had my out hit, what was it? It was, what was the type here? Raycast hit. Okay, so if I had raycast hit, out hit, and then I would do right? Like this would be the equivalent in. Yeah, no, yeah. So it out just gives you a reference. Is that what that does? What's their wording for that? C sharp. Out C sharp. You can use the out keyword in two contexts as a parameter and modify as a parameter modifier, which lets you pass an argument and by reference. Oh, I was right. Yeah, rather than by value. That makes sense. In a generic type parameter. Oh, this is kind of nice. Pass by reference. Always pass by reference if you can. In a generic type parameter declaration for interfaces and delegates, which specifies that the type parameter is invariant. Interesting. Following applies out keywords. Out parameters are not allowed in asynchronous methods. That makes sense. That I'd be surprised if if that wasn't the case. Out parameters are not allowed in iterator methods. I guess that also makes sense because you're clobbering things. Okay.
Now, let's create a float named current spring length to figure out how much the spring has contracted from its resting state. To do this, we'll subtract the wheel radius from the hit distance, which gives us the current length of the ray. When the spring is in its resting position, this calculation will be equal to the rest length, which we're using as the spring's length. Next, introduce another float named spring compression. This variable will hold the current compression of the spring, so we can apply force.
Oh, by the way, is there an easy way to draw an arrow? Like a debug arrow on the screen? In Unity? Because like I kind of looked it up and I didn't really see it. Unity draw debug arrow. Because like I was looking at this. Does it actually show up like that? Because if it does, that's kind of nice. But I would like to make them thicker. Okay, they're gizmos. You said there was an asset? Debug arrow. I'm guessing it's this one. This one looks really nice. But I also hate it. That's a really high poly fucking arrow. Do you need arrows? Have I got arrows for you? Twitch. There we go. Better gizmo. Damn, it's $15. I don't know if I like that. Am I signed in? Let me double check that. Let me sign in quickly. There we go. Sign in. Now I can set this to. I'm gonna do this. We're gonna say for. We'll do this. This is my wish list. There we go. These look really nice though. Mini tools. Orbital camera. I'm not entirely sure what this does. Boom, done. Your camera is now automated. You can use Cinemachine for an orbital camera. Okay. The thing that gets me here is these are very obviously Cinti stuff, so this does not come with that scene. This scene is not in that package that you buy. This one probably is though. There was one here, Dots City. There was one here that actually looked really, really cool. I don't think it was this one. Oh, it was this one. Yeah, this looks really cool and absolutely perfect for what I want. But I also don't know if this is something that I want. I don't know if I want to spend $100 on it. I wonder why his name is 604 Sprite. I'm also not a fan of the fact that he used generative images here. Like, why? You didn't need to. You had cool things right here. Like, this is cool. Anyways. You can definitely watch from YouTube. I'm not sure if you can. I'm not sure where you're at. Anyways, oh, welcome back. I was saying that I like that this looks really cool, and it proves that like my system can like you can do the thing that I want in Unity. But I don't like that this person used AI to generate an image for this. Oh yeah, no, I'm not spending $100 on this. Fmod though, this is worth it. I will probably grab this because I don't think that Unity has a built-in system that replaces Fmod. Just gonna add. I've read the Unity. I acknowledge. I agree to them. Yes, I know who Fmod is. There we go. Thank you. Please come again. The only add-on I do recommend is Odin, and Fmod is free. Yeah. Oh, Odin's great. Sorry, Fmod is great. I don't know if you've used it. You're talking about this guy, right? What exactly is this? Odin Inspector and Serializer. Interesting. I think some of these are probably potentially worth looking at once I get to a point that I've guaranteed that I am definitely going to go down the route of Unity. So you customize Unity and it helps serialize stuff in Unity. And no, save it for later. Wait for sales. Yeah, potentially. What's the validator though? I've really got to add in unit tests at some point. Wait, where were we? If you forget to add a reference in a game object, it will warn you and stuff like that. I thought it already did. What was this one? Show only attributes? When did I click over to this? Oh, right. I wanted to take a look at what exactly this was. And the answer is we don't know. Yeah, I have no idea what that does. Okay. So if I do, where were we? We were here, right? We're going to do this raycast, right? Let's come up here like so, there. And then we've got our truck here and our wheels. This is empty. These are probably going to be different in the future because we're going to want to add in stuff to this. A lot of what other add-ons do for editor stuff, Odin does better. That's fair and good to know. Wait, did I add Odin to my wish list? Wait, it was this one, right? Yeah, let me just add this to my wish list for now. There we go. Okay, so we come to here. I think I might want a struct custom wheel controller. If I want to make just a regular struct, I could just do this, right? This would be work, correct? Wheel controller? Public. There we go. Then we can do public wheel size. Maybe it would be a float, and then it'd be wheel radius. Public float, or sorry, Boolean is steerable, is motorized. There you go. Then I think we should be able to do this, right? Can I do this? Can't remember if you need to serialize. Apparently I can't hard code how many wheels it's going to be. Ah. Yeah, you need to serialize that one. Wait, no, this was serialized. Oh, does this need to be serialized? Like this? Is that what we're looking for? Yay! Dope. I do kind of wish that we had oh wait, this needs we can't attach the fuck. I can't attach my yeah. Damn. Okay. So if I do create script mono behavior, custom wheel controller. I don't think this is necessarily like a controller, right? I think this is like more of a custom wheel controller. Just gonna do this. And we can do this. Uh, is there, so it has to be a mono behavior, right? In order to do the attach, it can't just be like a data object, right? Can't be like, this is just data. Please only do data stuff with it. Yeah, that's what I thought. Okay. That kind of blows, but whatever. Okay, and then I need to do that layers thing. Is that under project settings? Do uh wait. Okay. Ah, here we go. Oh, interesting. Wait, how do I add to it? Give me a sec. I think that it was there. Unity layers. That's not what I was looking for.
Layers are used to indicate some functionality across many different game objects. Invisible, you can see that this orb is now on layers. We can do so using the Tag and Layer Manager window. Edit, Project Settings, Tags and Layers.
Project edit. Tags and layers. There it is. Hmm. Drivable. Would it be drivable or ground? Drivable sounds better. If you see in the inspector above the object transform, there is a layer you can click and see. Add that selected. Oh, here. Neat. Yeah, I see that. Oh, and then add layer. Okay. Yeah. That works. And then if we go here and we do project settings and we come back to, there's our layers. There's our rendering layers. But then the other one is under physics settings. Here we go. And drivable is checked for everything. Sweet. I think. Yeah. Hey, look, they did an enable disable all. Okay, then we got our, we're going to close a bunch of these for now. Okay. Then we come back to here. We come to our here, and then we've got, we need one more here, and then we do front right, front left, do, and do. And then in our case, this is steerable motorized, steerable motorized, motorized, motorized. And then our wheel radius. How do I find the wheel radius? I think I can just do this, right? .6 for the front. And then if we do a wheel collider rear, still 4.6. Oh, wait, this doesn't need a transform directly on it, right? Oh, wait. So if I've got this, we can do the transfer here can be, we can do that, right? Because it already has a transform. Yeah, so we can remove that and then we don't have to worry about that transform. There we go. Beautiful. I should really change this though. I feel like, no, because yeah, because I kind of want to have like serialized field, right? Private is for wheel drive, right? What? Oh yeah. Right, and then we can we do a default of like true? Do Unity serialized field with default value. Okay. Ooh. Like this, and then that will still allow that to be edited, right? So this will be instance editable, but will default to true. Okay. Ugh. is all-wheel drive. Can I do an enum? Enum. It's just that easy, right? And then if I do drive type, equals drive type dot all-wheel drive. Then I would be like, oh, right. Sorry. There we go. Okay. Then this wouldn't need a motorized. It'd be serialize field. No, you know what? Yeah, no, we don't need this. Because if the wheels tell us whether or not they're motorized, it doesn't matter anymore. There we go. Private. Yeah, I'm overcomplicating things as I think about it.
Accurately. It's calculated as the rest length of the spring minus the current spring length, showing how far the spring has moved from its rest position. Finally,
And then this allows us to do, what was it? It was header. Vehicle components. Go properties. And then this would be serialize field. Private float. Where is it? It was spring stiffness, rust length, spring travel, wheel radius. Yeah. And this is suspension. Suspension height. Where was this one?
Couch co-op. Actually, we'll pull back to go back to that rest distance.
Yeah, so we want a rest distance.
we divide this by the
Suspension rest distance. Suspension properties. To do.
And so the first number that's involved in this calculation is going to be the offset, which is basically just how far away are we from that rest distance. Now notice that this offset needs to be a signed value. So on one side it needs to be negative, and on the other side it needs to be positive. And this number is telling you which way to go and how far to go to get back to the rest distance. And actually, if you want to calculate a spring force, that's really all you need. You need to know the offset, and then you multiply that by some value that says how strong.
That's what it was. force.
The spring travel to scale the compression ratio.
That's not what I wanted.
Strong is this spring. So here's a quick example where we set the strength to 10, and if we push the spring and then let go, you can see this green line. Let me scale it down so it's easier to see on the screen. The green line is you can start playing with your spring fluid, which is resisting motion, the velocity, and the force is pushing to the right. And the size of the force is sort of relative. It's trying to push the spring back to its rest distance. And then we tack on this damping component that says, but by the way, the spring is resisting motion. And so now when I compress the spring and I let it go, you see we don't oscillate very much. In fact, we come to rest very quickly.
Oh, wait, no, it's dampening.
Yeah, you can see that.
Sorry, give me a second here. This
Go over step by
video
step all
is
the ways we
great.
calculate the forces required to make custom car physics in Unity. All right, welcome to our car test facility. Let's take a look at one of the cars from the game here. So Prim will give us a little demonstration of the handling of this high-quality sedan here. You can see we went with a pretty arcadey, kind of bouncy feel to the cars, but the techniques we're going to talk about today will actually work for simulating arcadey all the way to semi-realistic cars. All right, let's hop in the little test mobile here and talk about how these cars work in detail. So the first thing to mention out of the gate is that we went with a raycast-based approach. So that means that rather than actually simulating an individual rigid body for the main car and then an individual rigid body for each tire and connecting them with some kind of physics joints or something, there's actually only one rigid body going on here. So this is what this car looks like according to the physics system. It's somehow one rigid body that seems to be driving around as though it has tires and works like a car. And so that's actually what's going on here is that we are creating forces that we're applying to this one rigid body that make it behave like a car that has tires attached to it. Here's a look at those forces. You can see that there's 4 of them. So basically at the location of each tire, we're using raycast to find the ground underneath us, and then working out things like suspension and friction forces, and applying them to the main rigid body of the car at the location of each tire. And then the net result of these 4 forces is a single rigid body that drives around like a car. So you should be on the right track now. Cast some rays, calculate a force for each tire, and you've got a raycast car. Thanks, and don't forget to like and subscribe. Okay, obviously I'm going to have to go into more detail because look at these forces. They look totally confusing and complex. Like, how are these being calculated? What kind of crazy math is going on to make these wild forces that are constantly changing direction and changing their magnitude? Like, oh my gosh, I don't even know where to get started. Well, the good news is that while this looks really complicated, we can break this problem down and make it significantly simpler. And the first thing to realize is that the tires are basically like children of the car. And so what we did is we created 4 transforms that we attached to the car that represent sort of like the location of each wheel. If we look at one up close, we can see that actually we can think of a tire as actually having 3 individual forces that contribute to its effect on the car. And if I turn on a little visualization of these, we can see them independently. So here in the green direction, we have suspension. So if Prim bounces up and down on the car, we can see that the force in the green direction, that is the suspension, is sort of growing and shrinking depending on how much it needs to push to keep the car floating above the ground. And then in the blue direction, you have gas and brake. So you can see a force in the blue direction is the direction that the tire likes to roll in. And so here, if we push a force in the blue direction, we can speed up the car or we can slow down the car and apply brakes. And then finally, you have that red direction, which represents steering or sort of slipping. So if the tire was moving in the red direction, that would be bad, right? Tires don't like to slip. So what we end up doing is calculating a force in the red direction that reduces slipping. It says, I don't like to be moving in this direction. Stop any movement in this direction. I like to move in the blue direction, but not in the red direction. And we can think about these things separately. So actually, each tire on this car is actually just 3 numbers that we need to calculate. We need to calculate a number for the green force that says, what's the suspension doing? We need to calculate a number for the blue force that says, what are we doing for rolling and accelerating and braking? And we need to calculate a number for the red direction that says, how do we make sure we're not slipping and we're actually steering and rolling in the direction we want? And so that's what we're going to spend the rest of this video doing, is actually breaking down this problem into just 3 separate numbers that we calculate independently. And once you calculate that, you get the sum of all those forces, and that is the result for each tire. Okay, let's start with the green force we were talking about before, which is the suspension force, which is basically there's a spring attached to the tires that is holding the car up off the ground. And of course, we're talking about a spring here, so we're going to need to calculate a spring force. Now, first thing to realize about a spring is that a spring has a rest distance. It has a length that it likes to be. And then if you compress the spring, it will push back to go back to the rest distance. Or if you stretch the spring, it will pull back to go back to that rest distance.
Yeah.
So the first number that's
Okay, so I think I already have the rest distance. Yeah, suspension rest distance. Good.
involved in this calculation is going to be the offset, which is basically just how far away are we from that rest distance. Now notice this offset needs to be a signed value. So on one side it needs to be negative, and on the other side it needs to be positive. And this number is telling you which way to go and how far to go to get back to the rest distance. And actually, if you want to calculate a spring force, that's really all you need. You need to know the offset, and then you multiply that by some value that says how strong is this spring. So here's a quick example where we set the strength to 10, and if we push the spring and then let go, you can see this green line. Let me scale it down so it's easier to see on the screen. The green line is the force we're calculating, and the force is literally just the current offset times some number, which represents the strength of the spring. So when we're pushed all the way here to an offset of -0.4, then our force is -4, and if I stretch the spring the other way, we get a force just as strong in the opposite direction. And then you can start playing with values like this value for strength. What if we beef up the spring and give it a much thicker metal coil? Now you can see the force is a much higher value, and that results in a much faster oscillation. So the first step to calculating spring force is just to calculate the offset and multiply it by the strength of the spring. That gives you a force that you can apply directly. But you might be noticing that this spring seems to just bounce back and forth forever. And that's true. If you just have this much information, you get a spring that will bounce forever. Now, real shocks on cars and other kinds of springs have what's called a damper. It looks something like this. It's sort of like a plunger of some kind, and there's some fluid, and then this thing doesn't want to move. So when you try to push the spring now, it has to push the plunger through that fluid, which is resisting motion. And so that's literally what damping is referring to, is trying to slow down the motion of the spring. So we can represent this in code if we know one other thing, if we know the current velocity of the spring. So imagine the spring's bouncing back and forth. We can stop it at any point, and we can understand the velocity of the object the spring is attached to, in this case, the tire. And if we know that, we can calculate a damping force. So a damping force is basically trying to stop any motion. It wants to resist motion. So that's why you take velocity into account. And so if I give this thing a little nudge here, you can see that it quickly kills any motion. And this is happening with a force that's in the opposite direction of the velocity. So the velocity is headed to the left, and the force is pushing to the right. And the size of the force is sort of relative to how much velocity we have. You can see down there the force is just negative velocity times damping. And again, damping is just some number that we choose. In this case, you can think of damping as kind of representing how thick is the fluid that's inside that damper there. The thicker the fluid, the more it's going to resist motion. So then when we want to calculate a better spring, we combine these two elements. So now our force is equal to the offset times the strength, which is the part that's trying to push the spring back to its rest distance. And then we...
Yeah, and then we've got the dampening. Suspension...
tack on this damping component says, but by the way, the spring is resisting motion. And so now when I compress the spring and I let it go, you see we don't oscillate very much. In fact, we come to rest very quickly. So it starts to get a little complicated to look at all these arrows and kind of like really understand what's happening. But if I slow down a little bit, you can see that at the beginning here, when the spring was squished and we let go, that we have our offset is pretty big, and that times the strength is giving us a lot of force, saying go to the left. And right now our velocity is pretty small, so it's not doing much. But as we speed up here and we head towards the home position, look at that, our green force actually flips directions. And despite the fact that the spring still needs to go to the left to reach its rest position, our ultimate force right now is pushing in the other way. It's trying to slow this thing down, slow down, slow down, slow down. So that's the damping force counteracting the regular spring component to keep this thing from oscillating over and over again. And what's great about this is once you've got this formula, it's just 4 numbers, offset times strength minus velocity times damping. 2 of these numbers are numbers you just decide, the strength and the damping. And you get very different behaviors depending on what you set these numbers to. Here's an example of a spring with a strength of 100 and a damping of 1. So this thing is going to bounce back and forth a lot because the damping is very small. It has a small effect on the system. This would be like a spring with a really thick coil of metal and maybe just air inside the plunger. Now what if we change this and we say the damping is 30? We took the air out of the plunger and we just poured a bunch of honey in there. And so now this spring really is not going to want to move. So even if I compress it down and let it go with the same strength coil, it has to try really hard to push that spring because it's really resisting any kind of motion. And maybe somewhere in the middle, let's take out that honey and put oil inside, and now you get something that doesn't resist it too much. Let's get right back to the rest position, but doesn't overshoot very much. And so these are 2 numbers that you can then tune to get a spring to behave exactly how you like. Now one thing to keep in mind is that these numbers are relative to the mass involved. So imagine you had a really weak spring and you put it on a car, the car would just slam down to the ground because it was so heavy. Similarly here, depending on the mass of the objects that you're trying to affect with the spring, you might have to make the strength and the dampening bigger or smaller depending on the mass
What was
involved.
I watching? I don't know. Chowder Hurry family. Welcome, by the way. Welcome. I'm just going through some tutorials quickly.
So here we have again our final formula for.
I have to replace the current driving system in the game because when they enabled dots and I had to, which requires the new Unity physics plugin to also be enabled, the vehicle stopped working. So I was just like, yeah, I don't want to deal with that. I'm going to build my own.
A spring force. And this is what is called a dampened spring force because it has the damper involved. But basically, it's just 4 numbers. You got to work out the offset. How far away are we from our rest distance? Multiply that with the strength of the spring, and then subtract the velocity of the thing the spring is attached to, in the direction of the spring, by the way, times the damping, and then you get a spring force. So this is all we need to calculate that green force on our car. And here's a look at the actual code for the suspension force. And as you can see, this formula is basically implemented directly in the code. We do some setup to work out things like our offset and our velocity, but then we plug those in and we have our.
Okay, yeah. Yeah, that's really
our formula right
valid.
there, offset times strength minus velocity times damping, and then that force is applied at the position of this particular tire. Okay, so here's a look at a car with.
Okay, so we take that. We're gonna do the hit scan stuff that this guy's suggesting. And this is on, I think this needs to be void fixed update, not update, if I'm not mistaken. And then we do the ray cast hit, out hit, yeah, out hit. Okay, and then it was our rest length plus spring travel is our max length. So what we're going to do is we're going to